Hello, everyone. I'm Negar. I'm the Codeacademy Tbilisi AI and Machine Learning Chapter Leader. And this is Introduction to Numpy, part of a series that I'm planning to do on Numpy and Pandas. And, well, I actually had this event today, but then I recorded it and the video doesn't have my voice over it. So I decided to do this again. So you guys, like the guys that didn't join us, can, watch this video. And, others that joined the call maybe have some questions and they can go over it. So that's cool. Okay. So NumPy, numerical Python. So why do I need it? Well, NumPy has these things called Numpy Arrays, and they're basically Python lists, but spicier and fancier. And you might think, okay, why do I need it? Like, Python lists are actually pretty special as it is. You can hold a collection of values, you can hold different types of data, you can change, add, or remove stuff. So why do I need it? Well, there is this one important thing missing, which is the ability to perform a mathematical operation over all the items and at the same time. What do I mean by that? Okay, so here I have the heights and weights of my family members, two separate lists, and I want to calculate the BMI for each person. Now, when you're doing a mathematical operation, it's very important to you that it's fast, right? Because usually when you have like a data set of, 10,000 items, you don't want to wait, you want the most optimal solution to do the operation. So that means, like, in our head, we need our data to be like done by one line, maybe. Okay, now let's do this without NumPy. I get an error because Python has no idea what I'm saying, right? If I were to do this with Python, I would have to create a function and with the for loop and all sorts of stuff, which would not be even like close to optimal. So therefore, we have NumPy, which is really nice. So as I said, NumPy arrays are basically replacements or alternatives for Python lists. And, well, by the way, if you don't have NumPy installed, just run this code, this line of code, and it'll be fine. It usually takes like 1 minute or something. So since NumPy is a library or a module, we use import, like always, and it's conventional to use np. So I run it. Yeah, so we're running NumPy as np. And here I'm converting my normal list, Python list, into a NumPy array. Basically, you choose a variable name, you equal it, and then you have np numpy dot array, and inside of parentheses, you put in the list that you're trying to convert into a NumPy array. As easy as that. And then we do this. Well, we have it. That's nice. And if I check the type of it, I'm going to get a NumPy array, ND array actually. So what this is telling us, that can be a little bit confusing, is that NumPy has its own data types. So it's not like a Python list or a Python array or something like that. It's literally NumPy's special data type. Now, why is this happening? And why does NumPy need different type of data? And the answer is that NumPy has a secret. And that secret is that NumPy is running C in the background. Why? Because C is the fastest language out there. So yeah, that's why we have different data types, because NumPy is using C instead of just the usual Python stuff. Hence, it's really fast. Okay, I'm doing the same thing. I'm converting weights into an ND array. I did that. Now I'm calculating a BMI for every single person in my family. So I get weights. It's basically the formula for BMI. So weights divided by heights to the power of 2. And I can print it out. Yeah, I got it. These all look like BMI stuff, which is really cool. Now, one important note is that Numpy arrays can only contain one data type. But we remember that Python list could have any type of data inside of it. Now, let's see what happens. So imagine we have like an ordinary array. I have 2 as a string and 3. Now I'm gonna convert this into a NumPy array. So NP array equals to NumPy array. And then I'm going to print NumPy array. Okay, so here, something strange is happening. Basically, I have 2 integers and 1 string, right? But when I convert it into a NumPy array, I get all of them in string. So NumPy figured it would be easier to deal with everything if it just converted everything into a string. And yeah, and the type is basically shows what NumPy decided is the most optimal data type for the whole array. And you can search what everything means, but we don't really work with it that much. Like it's fine because NumPy does everything for us. So that's cool. That's oh yeah, and basically all of this is called type coercion, and you're gonna hear it a lot basically. Okay, now we know that when we had a sum of 2 just regular lists, for example, I have 1, 2, 3 here, and then I'm just summing example plus example. Okay, here I get 1, 2, 3, and then 1, 2, 3, right? Now, let's see what happens if 1, 2, 3 was a NumPy array. Yeah, I get 1 plus 1, 2, 2 plus 2, 4, and 3 plus 3, 6. Why? Because it's literally made for mathematical stuff. So yeah, this is very helpful. We can just sum everything up instead of using a for loop and stuff like that. So it's just a one-liner, which is very, very efficient. Now, let's talk about subsetting. So for lists, for example, if I want to access 2 here, which is index 1, I would just say example 1, and I would get 2. Actually, the same thing works for example NP or NumPy. If I say 1, I'm going to get 2. That's pretty easy. But NumPy arrays actually have more magic to them. For example, remember this guy, BMI? I'm going to print it out again here. And what if I wanted to know whether there are any items inside of my array that are above 30. So BMI is over 30. Okay, so a cool thing that you can do is just say BMI more than 30. And you get a list of, an array of Booleans. So it says true, false, 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 true, and false. Meaning this guy is true, meaning it's above 30, which is, yes. And we have this guy, 44, this true, that is above 30. That's pretty awesome as it is, but it gets even more legendary, which is you can actually get that list that are above 30. For example, you can say BMI brackets BMI above 30. And I actually get 30 and 44. You can even say BMI, give me everything that is less than 30. And I get every single item besides 30 and 44, which are above 30. So that's subsetting in arrays. Okay, now, here is a task. Oopsies, I have the answers already. Okay, so we have a list of heights of some baseball players named baseball. And what we have to do is to create a NumPy array from baseball. Just code along with me, it will be better. So I have to call it NP baseball, and I have to equal it to NP array parentheses baseball. And I have to print it out now. And yep, I get a NumPy array, which is cool. Now, I have the heights in inches now, and I need to create a NumPy array from heights in and NumPy height inches. Fine. So NP height in equals to NP array heights in inches. Okay, and then I have to print it out. Okay, run it till now. Yep, I've done it. Now I have to convert the heights in inches into heights in meters. And to do that, I have to multiply every single item by 0.025. Fine, okay. So NP height M equals to 0, well, actually, first we have to say NP height N multiplied by 0.025, and then I have to print NP height in meters. Yeah, seems fine. We've done it. Yeah. Okay, so this section is over. What we've done basically is now we have our height in meters, and well, here we have the height in kilograms. So we can now calculate the BMI. Okay, so first of all, I need to create weights NP, which is equal to NP array weights. And then I can say BMI equals to weights in NP divided by weights heights. What was the name of the variable? Sorry. NP height M powered by 2. And then I have to just say BMI. Oopsies, we had an error. Now we're fine. Yeah, so we have the BMI now. Everything's fine. We have 26, 20, 41, 31, stuff like that. We can actually play around with them now. For example, let's, slice them up a little bit. Let's say BMI, do we have anyone above 40? I have 1. Okay, now show me. I have 41 here. Okay, that's nice. Okay, now let's do a weird thing here. I told you guys that NumPy arrays only accept one type, right? One type of data. So, and they change whatever there is. Like, for example, they get an integer and then they see one string and then it changes into everything changes to a string. Now, here we're summing true 1, 2 plus 3 for false. Okay, so we have integers and booleans. Let's see what Python does. Well, NumPy, technically. Okay, we get 452. So what happened here? Okay, we know why 5 happened, because 1 plus 4 is 5, right? But here, true plus 3 has equaled 4, and 2 plus 0, well, 2 plus false has been 2. So it means true is 1 and false is 0, which makes sense because in binary, 1 means true and 0 means false. And that's a very cool way that NumPy takes in a Boolean and converts it into an integer. Now, let's see which code chunk builds the exact same Python object. Let's see. Okay, I'm going to print this out. Okay, first let's look at it. So it's true, 1, 2, 3, 4, false. So it's going to be 1, 2, 3, 4, 0. That's not equal to 4, 5, 2. We have 4, 3, 0 plus 0, 2, 2. That's going to be 4, 5, 2. Okay, that seems like that we already know this one. Let's print this out. Let's play around a little bit. Okay, so 1 plus 3, 4. 1 plus 4, 5. 2 minus 1, 1. So negative numbers are basically, how we do it in math. So that's that. And this one is basically just 0, 1, 2, 3, 4, 5. So we've decided that the second option is our answer, which is equal to this one. The last thing that I'm going to be discussing is n-dimensional NumPy arrays. So, for example, here for BMI, let's see what is the type of BMI. It is a NumPy ND array. Okay, we discussed why NumPy uses its own data types because it's C, it's fast. Okay, well, what the hell does ND array mean? ND array basically means n-dimensional array. Okay, n. It doesn't specify, it doesn't have a limit, which means we can have like 100-dimensional array. We can have as many dimensions as we want. Amazing. Let's explore that a little bit. Of course, I'm not going to discuss 100-dimensional arrays right now. Let's just go with 2 for now. I created a NumPy array called weight and height, and I've just put inside these guys and these guys. And pay attention that these are lists of lists. So these 2 lists are inside of a big list because that's how NumPy expects you to feed in data to it. And okay, now let's see what weight and height looks like. Oh, sorry, I didn't run this. Okay, so it literally gives us a 2-dimensional array. So we have rows and we have columns. Okay, now how do I, for example, get access to 1.92? Okay, so weight and height. Okay, so this is line 0. I mean row 0. Okay, so 0, 0, 1, 2, 3. 3. I get 192. So first you put in the row and then you put in the column. Exactly like math. So weight and height, 0, 3. I get the exact same result, but this one is more preferred because I think it makes more sense maybe. This looks a little bit too much C-like. So other stuff that you can do is basically slicing. For example, you can say weight and height. So we want row 0 and we want just everything from the start until this guy, which is 4. Now you might think, okay, so this is column 3. Why did you put in 4? The reason is that, as we know, in slicing in Python, the last number is not enclosed. So this is why, for example, if you want 1.5 inside, you have to say 5, because 5 itself is not going to be included in the slice. So this is how you access 1.52. You can do the same thing. For example, what if I want both rows? I can just say this. Did I not run it? Since, okay, sorry, 2. And I get my 2 rows and only the first 4 columns. And the last thing that I want to discuss is the fact that we can see the shape of our ND arrays. So if I say shape, I get 2 and 6. So 0, 1, 2, 3, 4, 5, and 0, 1. So we have 2 rows and 6 columns, which is what this is telling us. And yes, so thank you for listening to me. I think I spoke maybe too fast, but I hope this helps you understand what NumPy kind of is, like a vague idea maybe. And next time we're going to discuss pandas, which is, I think, is going to take maybe 2 or 3 sessions because it's, a lot more advanced. Make sure to install Jupyter if you haven't already. DM me or ask in the server if you have any questions, you're facing any errors or stuff, or something is unclear. Yeah, and see you soon.